Hello, my name is Darren Carvalho, and this video is about the IBM Advanced Data Science Capstone project. So let's get started with it.
Good morning, everyone. This is the PowerPoint presentation for my topic HR Analytics. In a company, selecting ideal employees for promotion has an entire process dedicated towards it. The use case that I have chosen is to simplify the selection process by picking candidates most suitable for promotion. I got the dataset from Kaggle. It's a binary classification problem to decide whether an employee is promoted or not based on various features that describe the performance and achievements of the employee. Here's a view of the dataset with various features like department, education, awards won, etc., and the target label is promoted. The dataset contains 14 columns and 54,808 rows. There are 9 numerical features of the type integer and 5 categorical of the type string. The target label is highly imbalanced in counts, more records of 0 class as compared to class 1. Features containing missing values are education with 4.39% missing values and previous year ratings with 7.52% missing values. The number of unique values in each feature are given below. Department, region, education, recruitment channel are nominal, meaning we cannot rank them. I have considered education as an ordinal feature with masters greater than bachelors greater than below secondary as the ranking. There are no numerical features that can qualify as continuous as almost all are discrete. As a part of initial data exploration, I have tried to answer three questions, starting with the number of promoted and non-promoted employees in each department. Most of the employees belong to sales and marketing, and most of the promoted ones also belong to the same. In terms of ratio of promoted to non-promoted department-wise, sales and marketing, operations, technology, and procurement share similar characteristics. The second question, as a part of initial data exploration, is to check the number of promoted and non-promoted employees with respect to their education. There are many employees with a bachelor's degree, but the percent of promoted employees by number of employees is greater in the case of masters and above. The third question is to answer the distribution of age and length of service. Most of the employees are in their late 20s and early 30s, giving it a slightly positively skewed distribution. The same type of distribution is observed for the length of service, with the peak being at 3 to 7 years of service. About the missing values, I have decided to impute missing values in education with mode as it's a categorical variable, and the missing values in previous year rating have been imputed with mean. The rest of the features have no missing values. Encoding categorical variables. In this, I have encoded education with masters as highest weight, then bachelor's, and then secondary. For the other categorical variables, I performed label encoding. As creating new features from existing one boosts the performance of the model. I tried multiple combinations of features, and these three combinations gave the best output in optimizing the model performance. Total score as average training score into the number of trainings, award underscore KPI as the number of awards won by the employee plus the KPI is met, experience as age minus the length of service. The correlation heat map between the features and target show no such feature that has a very great impact in deciding the target. The values are sorted in ascending and a maximum of 0.26 is the correlation coefficient. In order to normalize the data, I used min-max scaling with a range between 0 and 1. Since it is an highly imbalanced dataset, I used an upsampling approach with SMOTE, which stands for Synthetic Minority Oversampling Technique. For the model selection train test split, I used an 80-20 ratio on the dataset. I used 5 different algorithms on the dataset, and here are their performances. Random forest classifier with a hyperparameter tuning on criterion and number of estimators with grid search CV, and this gave the best model performance. The accuracy on test data was 95.6% and a consistent F1 score for both the classes. The deep learning algorithm I used was an artificial neural network model with 2 layers of activation ReLU and a loss function of binary cross entropy and an optimizer as gradient descent. The performance for this model was not very great but decent, with an accuracy of 78.6% and a little inconsistency in the F1 scores. The third model was an XGB classifier with tuning 5 hyperparameters using randomized search CV. The performance for this model was great with an accuracy of 87.9% and consistent F1 scores. Finally, I tried to compare the model performances with different algorithms like decision tree classifier and logistic regression, and both of these have given good outputs without any hyperparameter tuning, and the respective scores for each model have been plotted here. So let's go ahead with the code. So here is the code to my project titled HR Analytics of the IBM Advanced Data Science Capstone project. So I start by importing the dataset and the required libraries. So here is the preview of the dataset with the features and the target. I dropped the employee ID column because it does not have any relationship with the target variable, and here then I check for the null values where I had mentioned like 4.3% and 7.52% for education and previous year rating respectively. The unique values in categorical and numerical features are here, and so as I mentioned, the promoted versus non-promoted employees department wise, and then the promoted and non-promoted employees with respect to their education, and then the distribution of age, length of service and average training score. So as I had mentioned that the dataset is highly imbalanced. Here you can see that the 0 class has 91% of the values as compared to the 1 class. So I start with imputing the missing values on education with mode, which is bachelor's degree, and the previous year rating I imputed it using mean. Encoding categorical variables, I for education I used the masters greater than bachelor greater than secondary, like I had assigned the weights respectively, and for the rest of the variables I did a label encoding. Then comes feature creation. As I mentioned, these 3 features were the one which I had created in order to boost the performance of my algorithm, and then the correlation between the features and the target. Then here comes the oversampling approach, where I increased the number of one classes in order to get a balanced data set on the target variable. Then I did a min-max scalar transformation, and then finally defining all the models. Here random forest classifier, and here is the classification report. If the F1 score is consistent and an accuracy of 95.6. Then the artificial neural networks, 2 ReLU, then sigmoid with loss function as binary cross entropy and optimizer as gradient descent. So here is the accuracy of my artificial neural network, which is about 78.6%. Then I used an XGB classifier, which gave me an accuracy of 87.94%, and I tuned 5 hyperparameters here with using randomized search CV. Then finally comparing decision tree classifier and logistic regression to rest of the models, and this is the final accuracy score. Like the best performance was for random forest classifier, then for decision tree classifier. It's probably because most of the variables are discrete, and hence in the XGBoost classifier, since it optimizes the gradient, so that's why we got a little less performance as compared to the other models. So thank you.